Hi, I'm Everett and welcome back to the shop. This time what I've got is a job from work. Now my boss, who's also a friend of mine, booked in a while ago a gravel truck with a Cat C7 engine in it. This thing was leaking oil like a sieve all over, and the ring gear on the flywheel was all chewed up because the starter was loose. So we wound up having to yard the engine out of the thing anyway. So with it on stands, it got to the point where as it was coming apart, we wound up, changing gaskets and such. And on going to reassemble it, we found that we're going to have a bit of a challenge getting the rear main seal installed. Now Caterpillar, for the C7 engines, offers a seal like this with a repair sleeve, like a new wear sleeve on the inside. There's a special tool to install this that's available from Caterpillar for give or take a G-Note Canadian. The aftermarket ones are even a few $100. And, well, let's just say this is the weekend. He told me about it Friday, and it needs to, we need to start reassembling this engine on Monday. So rather than waiting for Amazon or one of those other ones, he said, hey, can you give me a hand with this one? So that's what we're up to. I don't have any 6-inch round stock because this is actually about 6 inches across, but I do have some various thicknesses of plates that I've gotten from a recent auction, so I'm just going to cut it out of a chunk of plate. Hope you find it interesting. Now, because I don't have a plasma cutter nor a torch, oxyacetylene torch, I'm going to have to do this the hard way with an angle grinder. So we're going to cut a square out and then knock the corners off, and then knock the corners off that with the lathe, off that octagon. The tool itself needs to be about 6 inches in diameter, so we're going to leave a little bit extra, like say 6 1/4. Try that again with a little better marker. Oh, that's better. Okay, so there's roughly our square. That was brilliant. So with that intersection at the center there, we take our center punch, put a ding, set this to 3 inches. This is going to give us an approximation of our outside diameter. Again, it's a rough guideline to make sure I behave, stay within the lines. There we go. Now, like I was saying before, this is going to be the hard way of doing this because, again, I don't have a torch nor a plasma cutter. So yes, it looked kind of awkward, but that was also partly just to see what I was doing. Yeah, this is going to take a while. I'll bring you back in when I have the blank cut out. Well, I finally got that piece cut off. Yeah, that took a while. It was noisy, smelly, and, well, let's just say I think I'm going to, now that it's small enough I can hold it, I think I'm going to take the corners off with the bandsaw. The thing is, I don't know what grade of steel this is. So the more I think about it, even if I used a plasma or a torch, I don't know if that would create extra edge hardening that could be a problem, so just cut it mechanically. Well, this little piece of metal here is rather ugly. We're gonna take the corners off and make it look better. Yes, it would have been better if I started with round stock, but I didn't have any. So what I'm gonna do is I've set up here, table's locked. I've already locked the head, whatever, and I've used my little pointer to find the center punch in the center there, and everything's locked, so we're on that axis. In order to take the corners off, because once I get the corners off, then I can actually mount it in a chuck as it sits, what we're going to do is use this bolt. This is formerly, well, this bolt formerly held the track bar in the front of a 3/4 ton or 1 ton Dodge pickup. I have the matching nut for it. And what we're going to do is we're going to drill a hole, mount it up on this, use it as an arbor because I've already center drilled the end of that. So use this as an arbor or mandrel or whatever you want to call it. To do that, we're going to drill this out. I don't actually have the right size of drill to do this, so I do, however, have an 11/16. We'll drill it out to 11/16, and if it doesn't fit, we'll just run a tap through just to make enough clearance for the threads. It'll be close enough. Spot drill first. Now, seeing as the bolt won't actually go into the hole, it's just a hair too small yet, like I say, we'll just run a tap into it. It's got the little hole in the end there. Because I don't have a spring-loaded tap follower, I'm just going to use that little center point again that I use for locating centers and such. Put in a 1/4 inch collet. This really won't take much because that bolt is almost in there. Use this to line up the backside, apply pressure with my right hand, tap with my left, give it a little bit of the tapping motion lotion. It's special. And I'm just waiting to snag that point on the back of my arm. These threads are all going to disappear later during a later machining operation, but that is at least a reasonable work holding method. We have a little bit of run out on the face as it runs, you'll see. Just a little bit, but I mean, for what we're doing, it'll be okay. It's going to get cleaned up afterward anyway. Right now what we need to do is make this rough, nasty octagon into a circle. That's going to take a little while. It's going to be interrupted cuts. It's going to be ugly. Here's hoping I don't break something in the process. Ha! Go figure. Oh, brother. You'd think I'd remember to turn the microphone on. So at this point what I'm doing is I'm boring the center out to 2.5 inches because I don't have anything like a dial indicator that goes longer than 2 inches, and I have to get out here farther than it'll reach. So as far as travel. So in order to do that, I need to have somewhere to step off against to measure from. So we're going to make this as darn close to 2.5 inches as we can. It's just going to be a relief for a stub on the back of the crankshaft, but I'm going to use it as a reference surface. Once it's ready, actually 2.25, so yeah, 2.305 is what I'm getting here. When it comes time to actually measure more precisely, I'm definitely going to use the like a snap gauge and a micrometer, but for now we'll just keep going the way we were. This one here. Yeah, 2.475 and a half. So that means I need to take 12 thousandths off on radius. That should give me the 24 thousandths I needed. Okay. Theoretically, here goes. Yeah, 2.50, I'll take it. Okay, so I got my 2-inch dial indicator set up here, set against the post. We're going to start making the first of the steps. What we need to do is make sure you have our 0 point. So this part's going to be carved away, so I'm just going to go till it touches. Right there. Yeah, we're just touched. There's our 0 point there. Touch there. And I'm going to bring my ways indicator to read 1 inch. So the first step goes in by 100 thousandths. Let's take 10 thou pass. There we go. Clean up that shoulder. All right. That should give us within a couple thousandths of 5.40, which is what I was looking for. So our next measurement we need off this is 1.313. All right, and our first test fitting will tell us that that's exactly what we're looking for. Just a smidge bit of clearance just because of the fact there's a bevel up top there. That is nice. I mean, it's also got a bit of heat to it, but that is exactly what I'm looking for. Now the next step only needs to be 40 thou deep, and the measurement I go out to on my dial gauge here is, or dial indicator, will be 1.251. I'll do that in 3 passes, 2 15s and a 10. What this does is this provides a extra bit of push on that wear sleeve to push it just past the chamfer on the back of the crankshaft. There we go. So if we take our seal, we should now have, oh yeah, there we go. And that is the, yep, and that's the difference we need to get this sleeve past the end of the crankshaft. All right, I like it. Yeah. It's a little warm to the touch, but yeah. So that's our new tool. I have to switch the jaws and we'll get on to the next part. We're going to cut the outside to its outside diameter. So I've swapped out the jaws. We're grabbing it from the inside now. We're now going to cut the outside diameter. It needs to be 6 inches. 6 inch, 138, give or take. So 138 thousandths to come off. 69 thousandths aside. And that should be that. Now you have to wiggle it just right to get the shortest distance. 6 inches. I'll take it. Oh man, if this stuff is just some interesting alloy. It strings like crazy. Seal fits in it nicely. Got room there to get the repair sleeve past the end of the crankshaft on the chamfer. I like it. I've already made the rotary table concentric with the quill of the machine. I've bumped the piece of work back and forth a bit to the point where, you know, I basically set it up concentric with the quill that way. Next step is we're going to find our 0 degree mark and then re-engage the worm. There we go. There, re-engage the worm. I still have to make a handle for this thing. So taking up our backlash right there, which is going to be there. Okay, that's our 0 for that. We can take our heater back off again. For my sanity check, I'm going to use this. We're just shy of 3 inches. So we can start counting. I've already taken the backlash out this way. So and there's 20 point, so yeah, and good. So that's back to where it says 33. Mark our Y. Should be right about there. There's a 1/4 inch hole. Here's our half. All right. Alright, so those are the 4 bolt holes. As I say, I'll chamfer and deburr them after. Now there's one more hole we need to drill. And we're going to keep going on here to 135 degrees, because that splits the difference between those 2 holes. Yeah, with the backlash taken up. And then we still have to move this table again. 2.25. One last hole. We can deburr it, and I can go to bed. Wait a minute, I screwed up. That was a mistake. But we're going to leave that one alone. We're going to go next to it a bit. Oh, it's too late. Alright. So it's not supposed to be 45 degrees over, it's supposed to be 22.5 degrees over. So there's 22 and a half. Yep, 22 and a half. That's where it's supposed to be going. Oh well. Just one little extra pockmark. The tool will still work, it's just more an embarrassment than anything. My fault is I was kind of going along with my plan, even though my original math on the plan was wrong. All right, there we go. Yeah, I made the mistake because for some reason I was thinking it was a 4-bolt pattern, but it's actually an 8-bolt pattern on the back of that crankshaft. So there we go. Ignore that little dot. Other than that, I'm going to deburr this and should be ready for tomorrow. So yeah, apart from that one little blemish, I'm actually I'm content with how it came out. I mean, the best thing is it fits the seal like it should. So tomorrow we should be able to get that C7 engine back together. Yeah, if anybody knows what sort of plate, like this was 3/4, I have some 1 inch as well. I got it at an auction from a mechanical company that went under last year, and they used to do pipeline type stuff too, as well as, you know, building and construction or whatever. So if you know what sort of stuff you'd be cutting pipe flanges out of, because that's actually, it was like flame cut or plasma cut or something to make pipe flanges. So if you happen to know what kind of steel that would be, it'd be kind of cool to know. It cuts really nicely and it leaves a nice finish. But anywho, that being said, just want to say thanks for watching. Thanks for subscribing. If you haven't subscribed, that's cool. Thanks for coming by. Hope you found it interesting. Thanks everybody for all the likes and the comments. It's, again, cool to hear from you. So otherwise, thanks again for everything, and I'll see you next time.